Today is the last lecture of the unit. Tomorrow we are going to have some in-class review time, and we are going to have a test on Friday. So we need to talk about fission, and it's not a lot, but we still have to take some time to talk about it. So one of the things that we need to go back in time and do is remember the things about that we've already learned about. So in this case, we've talked about fusion. We've talked about fusion in the fact that it's two atoms being fused together and they result in a new element. We talked about radiation, which is an unstable atom splitting apart into many parts. There's another definition in your notes for radiation where it's energy being transferred from one location to another. There's alpha radiation or alpha decay, in which case we have an unstable atom splitting into a new element and a helium nucleus. We had beta radiation or beta decay, in which an unstable atom splits into a new element and a high energy electron. And then we had gamma radiation, where light particles are given off in the form of photons. So that was our review. Today's new idea or concept is called fission. That's when an unstable atom is shot with a high-speed neutron and is split into two new atoms. There are neutrons that are released, and there is a large amount of energy that is also released. This diagram is similar to the one that you have in your notes. This part of the diagram in your notes isn't there, but I'm still going to use this diagram to talk about what's going on here. So the first thing that we have over here is we have the high-speed neutron. The high-speed neutron is being shot into the unstable nucleus of some atom, in this case, or radioactive atom. In this case, we're talking about uranium. The uranium absorbs it absorbs the high-speed neutron, and now the nucleus becomes even more unstable, and as a result of it becoming even more unstable, the nucleus splits and two new atoms result. In this case, krypton and barium. There is a lot of energy that's produced, and then another product or byproduct would be more neutrons are produced. So what ends up happening is that first neutron is like a seed that starts this reaction, and the next three neutrons that are given off go and find three more atoms of uranium, and they strike them and split them, and then those three more atoms are split into two atoms with three more neutrons each, and then they split. So it's a giant chain reaction, what ends up happening. And as a result of there being this giant chain reaction, a lot of energy is produced very, very quickly. So nuclear fission has sort of like an input side and an output side. The input side are our starting materials, so we start with an unstable atom and a high-speed electron. And the output side is like our products, where we get two new different atoms with extra neutrons and a lot of energy. So that's kind of how nuclear fission shakes out. So this chart is designed to help sort of give you an idea of the amount of energy that is produced through these reactions. So traditional fossil fuels, let's just say that they start with like 1 unit of energy. They produce all of the work that makes to produce them makes us give off like 1 unit of energy. Some common waste products are carbon dioxide, sulfur dioxide, nitrates, all things that aren't great for the environment. Fission, which is what we're talking about today, is basically 1,000 times the amount of energy produced from fossil fuels. And the byproduct of that is radioactive wastes, also not awesome for the environment. And then lastly, but the radioactive wastes, but it's considered to be clean because we can seal it and deal with it, which is different than the traditional fossil fuels, which we don't really have a lot of control over, and they end up becoming environmental pollution. The last thing is the first type of nuclear or atomic energy that we talked about, which was fusion. And in fusion, we produce roughly 4,000 times the amount of energy of traditional fossil fuels. And the nice thing about that is that helium is its only byproduct or waste. The problem with that is that the only place to do it is in a star, and we don't have the ability to harness a star currently. So when you're working with these nuclear fission types of problems, or sorry, yeah, fission types of problems, what ends up happening is we have to make sure that the numbers or the values on the left side of the arrow are the same or equal to the numbers of the values on the right side of the arrow. So what I've done here is I said that, okay, well, I have a uranium atom with being bombarded by a neutron, and so I noticed that 235 plus 1 is equal to 236. And for the atomic number, I noticed that I have 92 plus 0 gives me an atomic number total of 92 on the left-hand side of the arrow. Now on the right-hand side of the arrow, I know that I have 144, and I have 1 times 3, so that's 1 plus 1 plus 1. So the right side has to add up to 236. So what I do is I take 236 minus 144, minus 1, minus 1, minus 1 to get 89, and that 89 I'm going to put right here on top. So that's going to be my mass number for my new element that forms as a result of fission. And then for the bottom portion, my atomic numbers, I'm going to take 45 and 0 and 0 and 0, and I'm going to subtract them from 92. So when I subtract them from 92 minus 45, I get 47. And 47 is the value that I'm going to put for my atomic number on the bottom. And so then I go and I look for my handy dandy periodic table, and I take a look at the periodic table and note that the atomic number, the element with the atomic number 47 is silver, and so I just fill in the value, or the values and the elemental symbol in this case. Now, the last thing that I'm going to show you is a video. This is a video about nuclear power plants and how they work and are operating. It doesn't work with this particular format here, so I'm going to link it in the Google Classroom. I highly suggest you watch it. It's about 3.5 minutes. It's just an interesting take on how nuclear power plants work. Your homework is to do worksheet number 5, which is nuclear fission. It is a one-sider, and we will go through it tomorrow, and then in class we're going to start doing some review stuff to prepare for your test on Friday. Good luck.